Alright, so we'll spend a portion of this lesson working through the solutions of your third assessment task for Extension 1. You cannot mark on your papers, please, because I've still got to photocopy them on there, so get your books out, theory books out, and we can write them in there, anything you need to write up. You will get a copy of the full work solution, okay, but if we can all work through them now, just to improve our understanding, okay, that we're actually reflecting the exam from here on in. Right. So, the way you answer multiple choice question, okay, will be different most cases than how you answer extended response question, okay. So you've got to keep this in mind because your multiple choice questions are only worth 1 mark each, all right. And for some questions, if you actually go through the full set of working, you're looking at 2-3 marks, okay? So you're going to use up a lot of time for your solution, okay? So question 1, one example of how you can get quick marks in your multiple choice, okay? Now, I would actually put tan of 75 degrees into your calculator, okay? So when you put it in calculator, it's approximately 3.73 decimal like that. Okay. So from that, I'm going to then put all the put the multiple choice answers into the calculator, and then get the one that's equivalent to 3.73 ... Okay. So if I try to take away root 3, okay, that's equal to about 1.7 is about 0.3. Alright, so I can see straight away that's not the correct answer. Alright, so you're almost going through a process of elimination in your multiple choice. Okay, so step number 1 would be eliminate any obvious incorrect solution. Okay, so right there's no real great obvious incorrect. Okay, but as you go through the answers, you have 2 plus root 3, which is approximately equal to 3.73. Okay, and that would be the correct answer. Okay, of course the alternate way to do it is your double angle, your sum of 2 angles formula. Okay, so tan of 30 plus 45, expand that out, and then use your exact value for tan 30 and tan 45. Okay, but again, you're only getting 1 mark for this question. Alright, it would be much quicker to go through this process to get that 1 mark than to get through this process to get that 1 mark. Okay? Alright, so the answer was C in your multiple choice. Alright, question 2. The 10 cards are selected at random from a standard deck of cards. You need to find the number of combinations selected if there are 4 kings. Alright, so yes, there are 52 cards in a standard deck. Alright, 13 times 4. Alright, and you need to know that. That's assumed knowledge. Okay, so also you need to know that there are, on a standard die, if the numbers 1 through 6, with the opposite sides of the die added to 7. Okay, that's what you need to know. You also need to know things like there are 64 squares on a chessboard. Okay, those sort of things you need to know. Okay, so you need to be aware of them when you answer your question. Alright, so 10 cards selected at random. Okay, so find the combination selected if there are 4 kings. Now the word combination is the big hint there. Okay, so we're considering the in the topic of permutation then combination, considering as a combination. Alright, so in other words, we don't care what order we have these kings, alright, as long as there are 4 of them. Alright, so with my 10 cards, alright, so I know I want my kings, so they're going to take out the first 4 spots. Okay, again, doesn't matter the order, I'm just concerned with getting 4 kings. Alright, and then from the remaining set of cards, 48, remaining set of cards, and I'll need 6 of them. Alright, so there's 48 times the combination of any 6 that will match the conditions there. And because of the combination, we don't care about the order. There is nothing in the question to suggest order, and it actually has said the word combination. Alright, so again, we eliminate any obvious solutions. So I would say, in my thinking, 720 and 1152 seem too small. Okay, So I'll be looking at either the other two, and looking at that, having 64, almost 64.5 million probably seems too many. Okay, so you're making use of reading time, thinking about what you would think would be a sensible answer, and then during your working time actually verifying that. Okay, particularly with things with diagrams or like geometry questions and that sort of stuff in there. Okay, so once you do that combination, the calculation, sorry, you will get the answer at B. So any questions on that? Right, so question 3A, straight formula expansion. So you're expanding this, so I've chucked that in there for that reason. Okay, so often in your papers there will be another question in there, okay, that will tie into a previous question or into a later question to help your mind thinking. Alright, so basically this was the question I was thinking if you didn't think of the concept of just putting your solutions in the calculator and then selecting the correct one, okay, then you're getting thinking of the expansion of this and then relating this up. Now I can go back and do the multiple choice question. Okay, often the paper will be set out that way. Okay, so keep that in mind when you're answering it. Alright, so B, most people were able to get the value for R, which was 2, and alpha, which was 30 degrees. But I don't think anyone here got full 3 marks. Alright, so 2 sine of x plus 30 was equal to 1. Okay, so once you substitute into formulas, etc., and then you substitute in for what it equals to in the question. Okay, so there's not a full set of solutions. You will get that with when you get your papers back officially. We're just concerned about the process from here on in. Right, so you need the sine of x plus 30 is equal to a half. Okay, so once you've got sine of an angle, or cos of an angle, or tan of an angle, okay, this is where you then go to your basic angle result. Okay, so this is like saying sine of what angle equals a half in the first quadrant. The sine of 30. Okay, so the basic angle is 30 degrees, and then you consider your quadrant. So which quadrant do I need to look in? First and second. So sine is positive in the first and the second quadrant. Alright, so the angle, x plus 30, okay, so whatever's inside that bracket, is equal to the basic angle in the first quadrant, and in the second quadrant is an angle is 180 take away that basic angle. Okay, so 30 degrees and 150 degrees. Alright, so from that we need x, so that means we need to take away 30 from each of those solutions. So 0, 120. And you're also then going back and checking your domain for your solution. Okay, so the question was a 0 which is less than or equal to x, which is less than or equal to 360. Okay, so we've got a solution of 0. That means you need to include 360, the equivalent. Alright, 360 is the revolution, so you're back to the start. So unless you told me all three solutions, you show me the basic angle and you show me evidence of considering quadrants, okay, that's what you need to do to get your 4 marks. Okay, so your first mark was to get to that stage, tell me what R and alpha is. Okay, the second mark was to tell me the basic angle and the quadrants that you are considering, and the third mark came from all 3 correct solutions. Okay, any questions on that? Alright, not many people weren't well at all in this question at all. So this was straight out of your theory notes. So we all remember the question? Do we need to read through it again? Right, so the first part, we need to show the angle AQB is 141 degrees. Okay, so that triangle that's formed at the bottom, this is the point where you consider it as a top view. Okay, so you're looking straight down on top. Okay, so we have ship B over here, so you're on a helicopter or a plane looking straight down at the information. There's A, there's Q where the lighthouse is there. Right. We were told that A was due east of the lighthouse, so that's the right angle there.
Not so easy.
Yep. And we were told the bearing, okay, so the bearing of the ship B to the lighthouse, we were told that was 51 degrees. Okay, now using your alternate angle, this was 51 degrees there. Okay, but that was your 141 degrees. Okay, so the question said show, that is showing. Okay, you're drawing a diagram, you're writing information in there, and you are showing me that you understand why that is 141 degrees. Okay, now often questions are set out this way because if you could not get that part, right, you could use that information for a future part of the question. Okay, double I, show the AQ with H tan of 78 degrees. Alright, so I think Rob and Nicole, you both got this one? You didn't? Did you get that one? Yep. Okay, so diagrams are very useful, okay? Do not ever leave a question blank that you could have drawn a diagram for. Okay? You can at least show me a diagram, you might be eligible for a part mark, alright? Not for this question because it's only worth 1. So I'm looking at the question, H tan 78. So this is AQ here. This is the height, of the lighthouse. I'm seeing 10 and I'm seeing 78. Alright, so from an angle sum of the triangle, I can see this angle here is going to be 78 degrees. Alright, and that will be the key for this question. Alright, so your hypotenuse from the 78, that's the opposite, and that's the adjacent. So tan of the angle, 78 degree, is equal to opposite, which is AQ, over the adjacent, which is H. So, AQ is H, tan 78 degrees. Nice and simple. And again, it asks you to show. So this time I had to write an equation down so I can show it. Right? But again, if you could not get that, you could use that information for the future part of the question. Okay? There's the benefits of the show style question, because if you don't get it, you can use the information still. Okay? Just because you can't answer either or both of the first couple of questions doesn't mean you cannot continue on to the last part of the question. Okay, where the marks are. So by using a similar expression for BQ or otherwise, we need to calculate the combined height of the cliff and the lighthouse to the nearest metre. So the first part of the question, by using a similar expression for BQ. So this side's 11, B, Q and L. So this is trigonometry in 3 dimensions. We had to look at it from a top view down for the base. We now also need to look at it front on from the relative perspective of the sides. So the 3D style question is pretty much constructing it back to 2D, back to your basic trig works, and then putting them all together at the end. Okay. So using a similar approach, so this means this angle here is 79 degrees. This is H. Alright, so using similar I can just write straight away, BQ is going to be H10 of 79, recognising the pattern's the same. Okay, not going through all that working again. Well, not a lot, but once you recognise the concepts, don't do the working again, put it straight down. Alright, and then I'll go back to this first diagram. Alright, so I've got an expression for AQ, which is that one there, H10, 78, and I've got an expression BQ, H10, 79. I know the two ships are also 1 kilometre apart. So what do I have in that triangle? How many sides do I know? Technically 3. Right, because you have an expression for all 3 sides at least, or 2 of them at least, and you have an angle. Okay, so when we use the cosine rule, if you know all 3 sides and you want to find the angle, or if you know 2 sides and the included angle and you want to know the opposite side of that angle. Okay. So, 1 squared, so this is going to be in the format a squared equals b squared plus c squared minus 2cb cos of a. Alright, so this will be a, b, c. The a squared has to be there because I need to know the opposite angle. Okay, so that's why those two are like so. 1 squared, which is h tan 78 squared plus h tan 79 squared minus 2 h tan 78 h tan 79 times cos of 141 degrees. Okay, so again, if you didn't know, you couldn't show that was 141 degrees, you can still use it if you can recognise the principles for the last question. How many variables do I have in that equation? Just 1. And it's the variable we need in it. Okay, we need to find the combined height of the lighthouse and the cliff, which was variable h. So 1 h squared tan squared 78 plus h squared tan squared 79, take away 2 h squared tan 78 tan 79 times cos of 141. What does each term have? H squared, h squared, h squared. So now we can solve for h, can't we? If you did that, that would be fine. Okay, I don't need to write all that again down here. Alright, if you did that, I'll be fine with that. You show me the process. Yes, you know you need to do 1 over all that. Okay, and then of course we need to take the square root of both sides. Alright, at this point you should be saying, neglecting the negative square root. Remember, we can have 2 possible solutions for the equation, but applying that equation to the diagram, we need the height, we need the distance, since So you need to make that comment, okay? And it works out to 0.012 kilometres. So you ask for the nearest metre. Okay, so we all remember this, going through this in theory now? No? I do. Do you remember it? Yeah? Are there any questions on the process? Does everyone see how it works? Yep? Okay? Alright, so the T formulas, well done to Robin and Michaela for getting that. Excellent, just algebra. Through that, you can follow the solution if you want to have another look at it. Okay, but I want to talk specifically about the rest of the paper, permutation combination. Were there any other questions on trig before I move on to permutation combination? No? Alright, how many ways can the letters of the word mathematics be arranged? Alright, so first things first, how many letters are there in mathematics? I said it was 10, it's actually 11. So, 11 factorial on top. What else is the condition for the word mathematics?
M repeats.
Yep.
T repeats.
Yep.
And there's another one. A repeats.
Yeah, so you had mat. Alright, repeating letters. Alright? So you need to write on the bottom the number of times each letter repeat. Now how many times does M repeat? So it'll be 2 factorial. Alright, how many times does A repeat? And T. Okay? So most people got the 11 factorial part right. However, because you got the same word more than once, because of the same letters, okay? So that will be your solution for this question. Alright, B. Final table for poker tournament occurs when there's 6 players remaining from the entry field of 16 people. Right, how many arrangements? 16C6 is technically not correct. Alright, why not? Arrangement. The word there, when you see the word arrangement, means there is an order. Alright? So yes, so I can see how you, and when I marked your 2 papers and I saw it and I was thinking, I can see how you're thinking. I actually called Mr. Smith and I had a 5-minute discussion about this with him, and we both realised, yep, that's correct because of the word arrangement within the question. All right. If it said how many ways can 6 people, that would be considered a combination because you're not to suggest any order there. Okay. Yeah, they both did that, yeah. Because I marked one of yours first. Yeah, me and I actually got this one. It's good. I marked one of yours first, and I was thinking, oh, yeah, okay. And I put it to the side, and then I marked the other one, and I was like, all right. And then I rang Mr. Smith, because I was still at school, was wet up, and then marking it. And we had a discussion, and he said, yes, I can understand why they did it. However, the question specifically said the word arrangement. Right? And I know Mr. Smith had a chat with you in the canteen yesterday about it. Yes. I wasn't going to say anything until you've done all your assessments. Alright. Everyone got the concept that around 6 around the final table, okay? There's an order there, however, because it rotates around, we consider that first person in that spot and then the remaining 5 in any position around that table. Alright, now it gets interesting. One of you's got this. This seating is random. Find the probability that 3 particular people will sit together. 1, 2, 3. 1, 2, 3. Okay, so the probability 3 sit together. Right, so we have 3 seats together on the round table. So the first of the 3, how many ways can they sit in 3 seats next to each other? Okay, 3 factorial.
I did that too, but I was going to do that.
What would have occurred to us to put
I think maybe we counted 3 people together.
as 4?
No, 3 people together as 1, and then the other 3 as 3.
No, you just read there.
Yeah.
3 people as 1 and the other 3 as? Because the other 3 seats are together, aren't they?
That's right.
Ah.
Yes. So you're almost doubling, you are doubling this solution because half of them are one side and half of them are the other side in terms of the 3 seats next to each other. Okay? So, for 3 people to sit in these 3 seats, okay, so person A, person B, person C, the person A can sit in 3 different arrangements, person B can then sit in the remaining 2, and person C sits in 1. So 3 times 2 times 1, 3 factorial. Then you also have to consider the other 3 people into the other 3 seats. So person D, how many ways can they sit in 3 seats? 3, person E, 2, and person F, the last one. So 3 factorial times 3 factorial. Over the possible number arrangement around the table. Okay? Now I think I gave a mark if you were able to link that to the bottom of the fraction. Okay, but the full mark will be the full probability question done. Okay? Which works out to be 310, 3 over 10. Okay? So, yep, keeping all these in mind when you're thinking about your arrangements. Any questions on the poker table? Right, I think everyone's bombed out the last question.
Yeah.
Alright, let's have a look. Right, 4 people, 4 boys and 4 girls.
I got arrangements in that one, but I didn't get arrangements in that one. Oh
Yeah.
my God.
Exactly. So you need to look out for your keyword and then apply them. Alright? Now, the really good thing about this is everyone's probably got a lower mark than what they've been getting in the past. Okay? Which is actually will work in your favour right now. Alright, because I think all of you need the shot in your arm, okay, ready for your final exam. Okay? So now that you've had a bit of a, oh, I didn't go as well as I thought I would have for all the work I've done, okay, particularly you two, but remember your prelim mark overall for the end of your HSC is very insignificant compared to your HSC assessments and your actual HSC exam. Okay? But this mark will not have any great bearing of your overall final mark. Okay? But, like I said, it'll give you a bit of a shot in the arm in thinking about your preparation and your thinking ready for your final exam. Okay? Because that will be everything and that will be a true test of how well you understood everything in the course. Alright. So, how many arrangements are possible? Yep. Now, I actually personally gave the mark if you said 8 factorial. Okay? In other words, I did not need you to write the actual what 8 factorial equals. I do not know what the HSC conditions are. Alright? But I would think for a 1 mark question, that will be sufficient. But I will get that information and let you know. Alright, Matthew and Bree must sit next to each other. How many arrangements are possible? So again, the word arrangement, so you need to consider this as a permutation. However, when I did this question, I did not even use the formula, I just considered the number of seats and looked for patterns. Alright, so there are 8 seats in the cinema that all the 8 people are sitting into. Matthew and Bree, what condition do we need to set them? Together? That means, what else? What we'll need to do to answer the question in terms of them being together? Consider them as one person. That means we take away 1 seat. Okay? So, starting from the far left, they can occupy the first 2 seats. Okay? But from that, you can have Matthew on the far side and Brianna on the first side inside, or Brianna could be on the far side and Matthew into the first one inside. So this is technically 2. There are 2 factorial ways they can occupy 2 seats. Alright? And then we need to consider the remaining people. So from the remaining people, how many people can sit in this seat? 6. How many in this one? Okay, so this expression, what would you write to simplify that?
2 factorial times 7. 2 times 7.
2 factorial times 6 factorial. Okay, do another row. Good to see people doing diagrams, okay?
Wouldn't it be 7? Because they can sit, they're part of everything, they can sit in the middle row or the right.
We're getting there, yeah. We are getting there. So, from the far, now Matthew and Brianna can take the second, so the second and the third seat. That means the first and the fourth seat are free. Okay, so in other words, if you really want to consider it, you can do 8 there, and Matthew and Brianna sits in those 2 positions. Alright, so that'll be 2 factorial. How many ways of the remaining people, how many can fit in this one? I mean, how many arrangement? So 2 factorial times 6 factorial, same thing, isn't it? So what do we need to do at this point? Consider how many ways this can be done. Right? 1, 2, 3, 4, 5, 6, 7 positions they can sit. Okay? The arrangement is 2 factorial times 6 factorial times 7 different positions they can sit. But technically, there are 2 factorial ways they can occupy 2 seats, times 7 positions along the line, and then you need to consider the other 6 people. Okay? Now, 6 factorial times 7, just as a side note, what does that simplify to? 7 factorial. So yes, you could consider it as 2 factorial times 7 factorial. Okay? Yeah, does that make sense? Yes? Yep. Okay, so if you're not quite understanding these, you'll be... So for these 2 questions, I gave you a mark if you had a diagram and you were showing me in your diagram you were approaching the thinking. I could see what you were thinking from your diagram. If I could see that, I gave you a mark. Okay, the second mark came from that. Right, with the answer obviously. Okay, but again, I think if you left it like this, you might have been alright. Okay, but I left it like that as marking. Okay, so if you didn't quite get this pattern, alright, so what you would need to do is keep going. Alright, draw all your possible arrangement. Alright, obviously that will be a time constraint, so this will probably be a question that you would leave and come back to. Okay, you wouldn't spend all this time just for the sake of 1 mark in the final result. Okay, so this is where you would come back to the question after you've had a bit of a think about it. Right, and this is where your reading time is very important. You are already thinking about your combination, start visualising what the answer is going to look like. And then your writing time, you're actually confirming that. Alright, 3 of the boys dislike each other and want at least 2 other people sitting between each of them. How many arrangements are possible? And you are ignoring the condition in part 2. Okay? So, what's the key for that question? What are the key 2 words? At least. So, that means 2 people can separate. And it also means there's an arrangement where there are 3 people separating 2 boys. Okay? So, start your diagrams. 1, 2, 3, 4, 5, 6, 7, 8. So, we consider these combinations. So, consider where the boys can sit. Okay? So that's one possible arrangement where the 3 boys can sit so it meets a certain condition. So from that, how many ways can everyone else sit there? 5. The remaining 5 can sit there. Remaining 4, remaining 3, remaining 2, remaining 1. Okay? Now, from the 3 positions marked X, how many ways can the 3 boys sit in those 3 seats? 3 factorial. 3, 2,
I got
1.
I did 4 times 3.
I counted
But-
the boy that didn't dislike everyone as a special person.
One very special person.
I don't know why, but I did.
Right, so from that, what is the maths I can write?
4 times. Oh, 4 times 4 factorial.
Hey?
Is it 4 factorial?
3 factorial plus 5 factorial.
5. Yeah.
You've got 3 times 2 times 1, which is 3 factorial. Then you have 5 times 4 times 3 times 2 times 1, which is 5 factorial.
You have to, oh no, I'm thinking, I was thinking the different ways they can all sit.
Yes?
There's 4 different ways that they can sit.
Yes.
And then 3 factorial.
Go on ahead, go on. I get that.
We're getting there, yes. We're just jumping the gun a bit. Okay? So from that, you will need to then consider the next possible arrangement they can do. Alright, so you can shift them all over to the right one. Is the maths still the same? Okay. The 3 factorial times 5 factorial. So really, you are recognising pattern, and once you recognise the pattern, you can then write down your solution. So at this point, you need to work out how many ways those 3 boys can be seated. Okay? And you drew the same arrangement twice.
I don't know why I thought, I don't know what I was thinking. Why is he special? Oh.
Right, so one, so the question said at least 2 boys, so we can have 3 other people separating them. Alright, that works. And that works, doesn't it? Are there any other ways it can work? No. So we have 4 different ways this can work. Arrangement will equal 3 factorial times 5 factorial times 4 ways those 3 boys can sit in the row of 8 seats. Don't write 4 factorial. And don't write 6, because that's obviously not correct. At any point, did you look at the question and think, hang on, these 2 are the same?
I don't know why. Oh.
You had all the things
I
listed down the
did
page.
maths as him being the same with the girls, but I didn't actually draw. Even if he was counted as a separate person, that still would have been wrong, because there would have been 8. I don't know what I was thinking. I don't know.
Right, so is this clearer now?
Yeah.
You're thinking, yes, alright. So, that it's just recognising pattern, recognise one condition, and then recognising the pattern that follows from that. Okay? So again, 1 mark if you were able to show me a diagram that you were considering, and I could see that yes, you were meeting the conditions for the question from your diagram, and then your 2nd mark came from getting that. Okay? That's taken a bit longer than I anticipated, that's alright. We'll start parametrics on Wednesday. We're actually going to do extension linear function first because you need to do some calculus skills before we go to parametric equation. So we're going to start calculus and mathematics today. Yep. Or I might go through some questions today on the mathematics paper, but we will start calculus as the next topic whenever we start it, so that you can do the extension parametrics.
It's like the infamous calculus.
Yes.
I need to know what it is. When's the University of Wollongong open day?
15th.
Are you still going?
Probably, yeah.
Is that down in Wollongong or?
Can't come. But you can't, is it close enough?
That's the
You just come and like.